Okay, here we are. This is going to be part one of our 3.2.3 PowerPoint. We're going to go through the ideas in this part of the PowerPoint, and then the other half of our PowerPoint, I'll show you some example problems. And we're talking about beam analysis. How do we find the shear and the moment forces inside our beam? Well, we've already talked about this. Beams are the horizontal structural component used in floors and roofs, and they sometimes are called beams or girders or joists or stringers, a bunch of different names. And we're talking about when I put a load in the middle of a beam, the ends are supported, and so it ends up bending the beam down. Along the top of the beam we have compression, and along the bottom of the beam we have tension. And this creates shear and bending moments inside the beam. That's what we're going to calculate. We've seen this picture before, our beams and our girders. Our beams, the tributary weight is putting uniform load on our beams here. And then we also have uniform load from the tributary weight on our girders, as well as these point loads coming from the beams themselves. So we'll see both of those combinations when we do example problems. So static equilibrium. Equilibrium you may be familiar with from Principles of Engineering or from physics. Static equilibrium is when the sum of the forces is equal to 0 and the sum of the moments is equal to 0. And we'll be using those ideas in our calculations. Where the supports are at the bottom, we replace those with what we call reaction forces, and then we have our applied loads at the top. That'd be our dead load, live load, the different loads we've talked about. Reaction forces can be linear or rotational. If we're talking about linear, something that's going in a line, we're talking about shear reactions. And we use probably an F or an R, those are vector quantities for forces. And then rotational reactions are moments. That's something that's causing it to turn. I've given you a copy of this slide in your for your notes, and these are what the supports typically look like. There's a roller support, and it's sometimes drawn like this, and it's also sometimes drawn as just a plain circle. And this just shows that there's no support in the horizontal direction. This only gives us support in the vertical direction. A pin connection is drawn like this, or a lot of the time it's just drawn as a single triangle here, and it's showing that we've tacked this down. It means that we've got support in the vertical and horizontal direction. And a fixed support, you could think about that it's actually glued into this wall. It's actually connected in there firmly. So it has vertical and horizontal, but also it has a moment there. It means that it can't turn. This one, if I pushed up on it right here, it would spin around this one. This one is firmly glued in there, it can't move. Different types of beam design. This would be a simple beam, only has 2 reaction forces on the bottom. Continuous could be multiple supports underneath. And then cantilever means that it's only supported on one end, and that end is fixed, and then it sticks out like this. Good example of that would be a diving board. It's fixed on this end can move. Beam types. So this type is fixed on both sides, totally glued in on both sides. It can't move on either direction. Propped would be totally fixed on one end with just a support at the other, or an overhang. You see the overhang a lot in construction where this end is pinned and then you have a support here, but this end is actually just sticking out. This is going to be our first step when we do calculations. Is you'll see here's a fixed support. This is what I said, it looked like a triangle sometimes. And this is a roller support. Notice it's a circle. I said it could look like that. This is going to be our typical setup for our problems that we're going to do. And the first step we're going to do in our calculations is replace these supports with the reaction forces they go with. A roller support always just gets replaced with one arrow, and a pinned support always gets replaced with two. We're going to see in our calculations, if all of our other forces are vertical, this one's going to end up not making a difference, and it's going to end up being equal to 0. And finally, we have our equilibrium principles. We saw these in Principles of Engineering, and we're going to be applying these in our calculations. The sum of the forces in the y direction is equal to 0, the sum of the forces in the x direction is equal to 0, and the sum of the moments is equal to 0. If we have a pin connection here, a fixed connection here, the other thing we need to know is how to calculate moment. Moment is equal to the force times the perpendicular distance. So if my force is going this direction, the distance I'm actually measuring is perpendicular to the force. It's an easy formula, just force times distance, but the distance always has to be perpendicular. We'll be using this moment formula in our calculations. Okay, this is ending the end of part 1 of the PowerPoint video. Please watch PowerPoint part 2 so that you can see how to do these example problems.